Folks, I have here an interesting handout. This is something I've used in teaching geometry for quite a long time. And there's really a very neat story about it. But before I tell you that story, I want to let you know you can get a copy of this handout. If you go to the Unit 6 discussions, it will say Radian Handout. I do encourage you to get that and print that out or put it on your computer, and we'll talk about it. And hopefully, this will be interesting to you. Okay, first things first, a little just very brief look at this handout. If you notice that there's looks like a coordinate plane, and then there's two circles. The inner circle seems to be talking about degrees, and the outer circle seems to be talking about radians. And then you have a couple things here. You have cosine here, you have tangent over here to the side, and then you have these lines going around the unit circle. And of course, those lines are radians. So in other words, 1, 2, 3, 3.14, right, radians for pi. All right, well, this is part of an apparatus I use to help students understand a little bit about trigonometry. So let's explore this piece at a time. Okay, I'm using Geometry Sketchpad. So the first thing that I want to do is I want to draw a circle. Okay. All right, so let's see what I mean by that. Okay, so I have a center, I have a radius, and I have a point. Now what happens if I move this line across? We see that all of these points, if you would, are equidistant from that center point, and so we have our circle. That makes sense? So a circle is a locus or a whole collection of points. Okay, so here we go. We have our circle. Okay. Okay, now what we're going to do is we're going to draw an angle, a part of the circle. Okay, so my question is, I'm just curious what this angle is right here. Here, here, and here. Wonder what that angle is. Okay, so here it is right here. I've got letters, angle ABC, 38 degrees, okay? So I can move this around, okay? Now I think I'm going to go up to 180, and then I'm going to go backwards. Yeah, sorry about that. So it should be 360 all the way around. But here we go. We know 90, right? Okay. All right, so there you go. There's a good little picture of a circle and an angle. Now what I'm going to do is I'm going to put a grid on top of the circle, and let me just move C out of the way for a second. It didn't work out like I wanted it to. What I want to do is I want to make the circle have a radius of 1. Radius of 1. Okay, so let's see how that works. Let's see if I can move A around. A goes up to 1, left 1, down 1, to the right 1. Okay, see if I can move that C back. Okay, so I got it. Notice here that we have, what happened? We have this point on the circle, and notice I'm forming an angle with the two blue segments. Okay, now if you notice what I did, here is my triangle here. Here's my point A. Uh-oh, what happened there? Uh-oh, what happened? Okay, so here's point A, and notice I'm dragging it down to a small angle. There's angle ABC, and right up here to a 90-degree angle, right? Okay, so that red segment, the red segment is describing the height, or the Y. It's getting the maximum right here, and then it's like 0 right there. That makes sense? Okay, now what I did is the black BA is representing the radius of the circle. That distance is always going to be 1. okay? And also the triangle I have here in quadrant 1, the red is the up and down, and the blue is the left and right. Notice that when the angle is very small, the blue is big and the red is very, very small, or 0. Then as I get closer to 90 degrees, notice that the B, or the blue, is getting very, very small, and the red gets to its maximum height. Now the red and the black are the same, right? The red and the black are same, so they're both one unit. And here the blue and the black are the same. You get beat up with that idea, that's for sure. But anyway, there's a little picture of a triangle on a circle with a unit radius, or a radius of 1. Okay, so now I put the two together on one sheet, and if you notice, if I move D around, the angle gets bigger, the red gets bigger, the blue gets smaller, okay? And then here the blue is getting bigger, the red is getting smaller, and now the D is under the x-axis. Okay, so we can have a cycle here. Also, if you notice that we have we have 0 degrees and 0 radians. We have 1 radian, which is close to 57 degrees. We have pi over 2, which is 90 degrees. We have 135 degrees, which also matches the red and the blue are the same length. Does that make sense? Okay. Whoops. And now we're down at pi, or 180 degrees. And again, we can go around and around. So let's just take the black for a second. 1 radian, 2 radians, 3, 4, 5, 6, 6.28. That would be how many radians or radiuses around a circle. So I hope that does make sense. Another thing that we could kind of notice here in the picture is that there's a scale at the bottom here with the cosine. So for example, if I did cosine of 30 degrees, that's 0.87, which is radical 3 over 2. If I did cosine of 45 degrees, remember it's the blue over the black, which is 1, okay? And that's going to be 0.71, which is pi over 2, 1 over pi over 2. And then 60 degrees. Cosine of 60 degrees is 0.5, and if you notice, it is right around there. I guess one thing that's a little interesting is, what about tangent? What about tangent? That's that's kind of an interesting question. So I'm going to make another line here. Let's color it. How about green? Okay. So if you notice, when I'm moving this point, the tangent starts out very small. Why is it very small? Because it's the y over the x, a very small red to a blue that's about 1. And then tangent grows, okay? Now let's see if we could get close to 45 degrees. Close to 45 degrees. Well, that is very close to 1. If you notice, 0.9, 0.95, and 1. So hopefully that makes sense. Also notice that that green line is going to go way high up there, okay? This scale over here to the right is going to get huge. And notice also that the red line is approaching 1, but the blue line is approaching a very, very small number, 0.1, right? So that kind of gives you an idea of how the values work when you're trying to get your mind around sine, cosine, and tangent. I certainly hope that helped you out.